January 30, 1864. The Confederate warship CSS Alabama is cutting through the Milky Sea. There is no moon. The sky is a void of black velvet and stars. Suddenly, Captain Raphael Sams notices something that shouldn't exist. He writes in his journal, "We suddenly passed into a patch of water so wide that it startled me. Around the horizon, there was a subdued glare, as though there were distant illumination. The whole face of nature seemed changed." For over 400 years, accounts like this were dismissed as a mariner's lore, ghost stories told by sailors who had spent too many months at sea. They called it the Milky Sea. They described sailing over fields of snow or clouds. But unlike the typical bioluminescence you might see in a breaking wave, which flashes and sparkles when disturbed, Milky Seas are different. They're steady, they're massive, and they're silent. The scientific community had a problem. To produce a glow this uniform over an area the size of a small country, you would need trillions upon trillions of organisms glowing in perfect synchronization. For a century, we didn't have a single photo. We didn't have a sample. We only had the word of spooked sailors, until the stars started looking back. Meet the culprit, Vibrio havii. It is a common marine bacterium, but it has a superpower. It doesn't glow to scare off predators like a jellyfish or a dinoflagellate. It glows to be noticed. Most bioluminescence is a burglar alarm. When a fish swims through a cloud of plankton, they flash to expose the fish to its predators. But Milky Seas are a lure. Vibrio havii is a saprophytic bacterium. It lives on organic matter, but the open ocean is the desert. The holy grail of these bacteria is the gut of a fish, where nutrients are bottomless. By glowing together, they turn a tiny speck of debris into a glowing beacon. A fish sees the light, eats the debris, and the bacteria get a free ride into a nutrient-rich home. But here is the serious scientific part. Glowing is expensive. It costs a cell a massive amount of metabolic energy. If one bacterium glows alone in the ocean, no fish will see it. It's a waste of resources. So they use quorum sensing. Every bacterium constantly secretes a signaling molecule called an autoinducer. In the vast ocean, these molecules just float away. But when the population density becomes high, roughly 100 million cells per millimeter, the concentration of these molecules hits a tipping point. This is a biological town hall meeting. Once the signal hits the threshold, every single bacterium switches its luxopron, the genetic machinery for light, at the exact same time. This isn't just a colony. It is a coordinated biological machine spanning thousands of square kilometers. For decades, we tried to find these from space using traditional satellites. We failed. Why? Because Milky Seas are actually quite dim. They look bright to a dark-adapted human eye, but to a standard satellite, they're lost in the noise of the atmosphere. In 2004, Dr. Stephen Miller of Colorado State University had an idea. He took an old report from a merchant vessel, the SS Lima, which reported the Milky Sea off the coast of Somalia in 1995. He then went back to archival data from the Defense Meteorological Satellite Program, or DMSP. There it was, a smudge of light the size of Connecticut, visible from 500 miles up. It was the first time science had captured the ghost. But the real breakthrough came in 2011 with the launch of the SOMI MPP satellite, carrying the VIIRS day and night band or DMB sensor. This sensor is a marvel of physics. It is sensitive enough to see a single glowing light bulb from space. The DMB doesn't just take a picture. It uses the technique to filter out air glow, the natural luminescence of the Earth's atmosphere. By subtracting the air glow, Miller and his team could finally see the ocean surface with unprecedented clarity. In 2022, they published a landmark study in Nature. They hadn't just found one Milky Sea, they found 12 massive events that had occurred between 2012 and 2021. The largest, south of Java in 2019, stayed active for 45 days and covered 100,000 square kilometers. That's an area larger than the state of Indiana, glowing with the power of a trillion bacteria, all communicating in a language of chemistry and light. But even with the satellites, we were still missing the ground truth. We were seeing the glow from above, but we didn't know what it felt like to be inside it, until a private yacht named the Ganesha sailed straight into the heart of 2019 Java event. Why here? And why then? In 2019, the Java event wasn't just a random occurrence. It was a result of a massive climate gear shift called the Indian Ocean Dipole, or IOD. Think of the IOD as the El Niño of the Indian Ocean. In its positive phase, which was record-breaking in 2019, strong winds push warm surface water toward Africa. This leaves a vacuum near Indonesia, which is filled by cold, nutrient-rich water rising from the deep. This is called upwelling. This upwelling creates a biological buffet. First come the microscopic algae, phytoplankton. They bloom in such massive numbers that they can be seen from the space as green swells. But as these algae die, they create a massive amount of marine snow, organic debris, and mucus falling through the water column. This is the spark. The Vibrio-Havii bacteria latch onto this debris. In the calm, stable waters of the maritime continent, these blooms aren't broken up by storms. They drift, they feed, and they multiply until they hit that magic quorum sensing threshold. Others often report a molten lead effect during these events. Scientists believe the organic mucus from the massive algal blooms actually dampens the waves. The sea becomes eerily flat, reflecting the bacterial glow like a giant liquid mirror. It is a perfect alignment of oceanography, climate, and microbiology. For years, Dr. Stephen Miller had the satellite data, but he lacked the witness. That changed when he was contacted by the crew of the yacht Ganesha. In August 2019, they were sailing south of Java when they entered a sea of snow. The crew described the glow as intense and uniform. They noted that the light didn't come from the wake of the ship. It was everywhere, extending to the horizon in all directions. One crew member noted that the glow was so bright they could see the details of the boat's hull and sails in total darkness. This was the smoking gun. For the first time, we had a GPS-verified human encounter that perfectly matched the satellite detection. The crew even took a photo. It is not a National Geographic quality photo, but it is one of the most important images in modern oceanography. It proved that the ghosts seen by 19th century sailors were exactly what the 21st century satellites were tracking. As we look to the future, the Milky Sea remains a white whale. We still don't know how deep the glow goes, or exactly how these massive blooms affect the global carbon cycle. but we are no longer sailing in the dark. From the handwritten logs of 1864 to the digital sensors of 2026, we have moved the Milky Sea from the realm of myth into the light of science. It reminds us that even in a world we think we've mapped, the ocean still holds secrets vast enough to outshine the stars.